IGCSE Computer Science Syllabus Statement 1.2.1f show understanding of the use of serial and parallel data transmission. So here we're going to be talking about one use of serial and one use of parallel, and that's going to be USBs and integrated circuits respectively. So let's begin. But before that, I'm just wondering if you guys noticed that I skipped 2 syllabus statements from this topic. Now, if you're wondering why, this is because we've already covered parity checking. So what would the point of doing it again be? Like we already covered an entire video about it, and I think that the statements have already been covered in that video. If not, you can kind of link them together, but that should pretty much cover everything, that video. Don't know why they have it too. I mean, I guess parity checking is a little bit like parity itself. It's a little bit like both, like, topics, but still, it's a bit weird. Alright, so let's begin. So let's start with USB. So you may notice the symbol and this thumb drive, which most people usually use. And USB stands for Universal Serial Bus, if you didn't know. And it's an asynchronous serial data transmission method. And it's a common method of transferring data between devices, as you may know, because, like, if you look at your phone charger, for example, or like if you have a hard drive or thumb drive at home, you'll notice that the USB port, which is this little thing right here, is quite common, actually. What is that sound? I heard something. Not the piano playing, if you can hear it. That's just my brother. Anyway, and it consists of 4 wires. 2 are used for power and the Earth, not the planet Earth, the physics Earth, and the other 2 are used for data transmission. So yeah, it's pretty common. It's a pretty common method of data transmission. So, like, you pretty much see it everywhere nowadays. And we'll talk about the advantages soon. So when a USB device is plugged into a computer, such as a thumb drive, if you plug it into your computer, the computer will automatically detect that a device is present. And the device is automatically recognized, and a device driver is loaded so that the computer can communicate with the device. So it's sort of like we were talking about with MIDI devices. Like, you're going to need a MIDI device in order to read MIDI files. It's kind of like that. And if a new device is detected, the computer will try to find the device driver matching the device. And if this can't be found, well, the user will have to do it manually. And, yeah, let's move on to the advantages and disadvantages. So, an advantage of USB is different transmission rates exist. And USB connectors can only fit in one way, which prevents incorrect connections being made. Now, some might debate that this is a disadvantage, because we have some, we have some ports, or like cables or whatever, which can plug in both ways, like the Apple iPhone, iPad, iPod charger, which can fit in both ways. So some might debate about that, but of course it prevents incorrect connections being made. Because, like, if you look at the I'm just gonna pick up a USB cable here. If you look at the port, you'll notice the two holes. One is more steep a little bit than the other, and that's usually that side up when you plug it into a device. You'll also notice, if you look into port, that sometimes you'll see this kind of small, can't really describe it, like kind of small bar and like a hollow space. So, like, if you look into your, alright, never mind, let's move on. Newer versions of USB devices are backwards compatible with older versions, and that can be an advantage, actually. And computers automatically detect USB devices and automatically upload device drivers, as we've discussed. And of course, it's a common transmission method, so many devices support it. Disadvantages include the maximum transmission rate being less than 500 megabits per second, which is around 62.5 megabytes per second. And presently, the maximum cable length is 5 meters. Now note that this video was made around Jan 2016, so if you're watching this, like in the future, in the near future, this might have changed, so keep that in mind. So the syllabus may be updated, but the content here should be good until like, I believe 2019. Alright. And of course, older versions, which were described somewhere here. Yeah, here we go. The older versions may not be supported. That basically means that in the future, like, they might be outdated and devices may not support it. That's pretty much it. So, integrated circuits, well, they use parallel data transmission. And now this is due to the need for high-speed data transfer, which can't be achieved by serial data transmission, as we've discussed in the earlier video. And of course, an internal clock is used for correct timing of data transfer, which makes it synchronous. So remember, synchronous and asynchronous data transmission. But the short distances make it less risky to do this. Now, this sort of leads on to what we learned about the disadvantages of using parallel and synchronized data transmission. The timing, and like the bits becoming skewed, like unsynchronized. Well, the thing is, with this, since it's such a short distance, this doesn't really pose a problem. Like, if you were to if you were to transmit data using parallel data transmission halfway across the world, then yeah, that might pose a problem. But with such a short distance, it might not, and therefore you can get high speed with less risk. So that's pretty much all there is for this topic, and please stay tuned for well, security, which already has its own topic. I don't know why it's here, but whatever, I'm just going syllabus order, kinda.